Hello, good morning. Thank you. Okay, hello everyone. This is our first week on the introduction to electric drive system. Our main course in this semester, electric drives. Electric drives actually they connected with the electromechanical energy conversion course. So if you have any interested in the electric machine, electric vehicle, pump and compressor system, also HVAC system, and electric train, etc. This course will be a good choice for you. Actually, we focus on this course MATLAB Simulink based electric machine and drive system simulation. We have nearly 13 or 14 week course. Generally, it will take a 1 hour long, actually. Because the faculty elective course generally takes time 1 hour, nearly, actually 1 hour is enough. We will focus MATLAB, I said you. Generally, it's the implementation and simulation based course. We will make some simulation about the electric machine control system, sometimes drive systems based, battery management, etc. In third year, you remember we have electromechanical energy conversion and control system. In the third year, second semester, we have power electronic course. Now they continue with the electric drive system. Why is the important electric drive system? Maybe this week we have no homework, but after next week, after third week, I will give you lots of homework, lots of simulation, lots of uh, modeling solution. Probably end of this course you have a small or starting expert about the electric drive system. Okay, now we can say advances in power electronics, adjustable speed electric drives. They offer great opportunity in some application. For example, pump. For example, compressor. For example, CNC machine. For example, precision motion control in automated factory, industry 4.0, etc. Also wind electric system, also electric vehicle. Okay, we are main focusing industrial area. These are automated factories, wind turbine, elevator system, electric vehicle, and pump. End of this course, I will give you some example, some simulation, some result and discussion about these most important 5 area. In your screen, you see classical adjustable speed drives. Why is important adjustable speed drive? This is the faculty elective course, yes. We have some students from computer and software engineering. Yes, you're right. It is good choice, I think. But you need to learn some electric machine characteristic. What is the electric machine? You know that this is the first course, so I will give some brief, some very easy example, very easy definition, etc. Okay, probably you will be bored. Electric machine have now been in existence for over a century. You know, from Tesla, we have electric machine, nearly 150 years. In classical information, electric machine convert electric power to the mechanical power. It's classical sentences. All of us are familiar with the basic function of electric motors in to drive mechanical loads by converting electric energy. In your home, probably you will see lots of electric machine application: ventilator, air conditioner, dishing machine, washing machine, refrigerator, some hair machine, in your kitchen mixer, etc. In the absence of any control, electric motors operate at essentially a constant speed. For example, in your hair drying machine, you have one mode, two mode, and zero mode. You can imagine if we have no control circuit in hair dryer machine, it will be operate in same constant speed. We cannot regulate the speed of the fan. With the electric drive system, we can operate in different speed range. For example, when the compressor motor, in refrigerator turns on, it runs at a constant speed. Before 2000, you know, lots of refrigerator operates in same temperature. Its main reason we have no electric drive system because power electronic system has not been developed, control system has not been developed, electric drive system has not been developed. But now we have lots of opportunity. For example, in your home you have air conditioner, companies sell them inverter controlled air conditioner. It is the magical word, inverter control air conditioner. Why we can use inverter? Because if you use inverter, you can regulate your speed. If you have no inverter, you can operate only same temperature. Maybe you can use some temperature detection sensor, etc. But it's not energy efficient. Okay. Traditionally, motors were operated uncontrolled in this application, running at a constant speed, even in application where efficient control over their speed could be very advantageous. For example, consider the process industry, which one? Chemical factory, etc., where the flow rates of gas and fluid often need to be controlled. In next slide, probably, wait me, no, one of them, yes. In this figure, you can see a pump. In a pump driven at a constant speed, a throttle we have. Throttle is valve control for flow rate. Here we have a constant frequency. This is the grid. It's called as a grid. Constant frequency in your home, 220 volt or 230 volt AC grid. We connect directly motor, and then we have a throttling valve. Also, we have a pump. In this application, motor running at grid frequency. What's the grid frequency? 50 Hertz. Motor running at 50 Hertz and pump running at only 50 Hertz. This is good, no problem. But we want the automated system. For example, your temperature, your pressure, your any measurement unit will be changed. If your pump rotates on only constant speed, This is not a efficient, not a automation system. For automation, we will implement motor drive system. You can see in next figure. Okay. In the process industry, generally all manufacturer company have variable speed drive, variable speed drive, yes. Like this one, we can add adjustable speed drive, motor, pump, and here we have adjustable speed drive. With the adjustable speed drive, control the pump speed to match the flow requirement. How much flow requirement we need? We can measure with the sensor and then sensor give a message. Adjustable speed drive, control the motor. Okay, in this course, our main aim, adjustable speed drive system design, control technique development, its modeling, it is maybe implementation, I don't know. Okay, why is the importance? Systems, all systems actually, electric vehicle, wind turbine, etc. Systems with adjustable speed drives are much easier to automate and offer much higher energy efficiency and lower maintenance than the traditional system. We have three advantages. I say again, automation, energy efficiency, and lower maintenance. Maybe we can add something. These improvements are not limited to the process industry. I said sometimes, for example, electric vehicle, etc. Electric drive speed and position control are increasingly being used in the variety of manufacturing. Lots of students know CNC, lots of students know elevator, lots of students know electric vehicle, etc. Their speed or their torque, their power, their position are controllable. If we have a control capability, we have electric drive system in that application. Okay, what is an electric motor drive? Good. This figure shows us the block diagram of an electric motor drive system. In this course, we will learn this unit step by step. In response to an input command, where is input command? Here. In electric drive system, we need input command. What is the input command? Sometimes speed, sometimes torque, sometimes position. The controller, by comparing the input command for speed or position with the actual values measured through sensor. Where is the sensor? Here. Sensor measure real, actual speed or position. We will define what's sensor. Now we can say only sensor. This sensor measure speed or position as a real, as a actual, as a measured value of speed or position. Okay. And then sensor send a message to the controller. Motor wheel speed is blah blah blah. Also, we have reference command here, input command. We measure the actual speed, we send reference speed. Probably in realistic situation, we have error with the speed, real speed and reference speed. For example, my reference speed 1000 revolution per minute, my actual speed 990. We have a 10 RPM error in this application. Our controller, generally, it is a software. It try to eliminate this 10 RPM error. Okay. My main role in this drive system, controller role, also sensor. Controller send to message, power electronic unit. In motor control application, we are using inverter. Inverter create gating signal for motor rotating function. This section we learn power electronic course. Okay, you remember. Motor, you learn electromechanical energy conversion. Electric source, you learn fundamentals of power system. Sensors and controller, you learn in control system. Now we will orchestrate them as a one part electric drive system. Okay. If you have any problem in this course, for example, if you have a understand the power electronic unit, you can revise your power electronic knowledge from third year. If you have any problem in motor definition, motor characteristic, etc., you can revise your knowledge in electromechanical energy conversion. If you have a problem, controller and sensor, you can revise your knowledge in control system. Okay, this is important for our course. We can continue. Maybe we can say something in this figure. The power processing unit gets its power from the utility source with single phase or three phase sinusoidal voltage of a fixed frequency. Okay, what's the fixed frequency and constant amplitude? In our grid, generally, in your home, I said you 230 volt at 50 hertz. It's meaning that fixed frequency, sinusoidal, single phase voltage. Okay. The power processing unit, in response to the control inputs, efficiently converts these fixed form input voltage into an output of the appropriate form. If you want to regulate your motor, for example, 50 hertz in your machine, in your electric motor, it it is equal to, for example, 3000 revolution per minute. It's meaning that if you have 50 hertz, your motor will be rotate at 3000 revolution per minute. But if you want to regulate its speed, you can regulate the grid frequency. For example, if you want to rotate your motor at 1500 revolution per minute, you need 25 hertz. For success this, you can regulate and efficiently convert input voltage and the input frequency. Okay, the input command here, interesting point we have. This is the microcontroller actually. Input command, microcontroller software. This is the semiconductor, you remember, power electronic. This is the mechanical motor. Sensor is a part, but here we have controller and input command. Actually, this is computer application. This is the microcontroller or single board computer application. Okay. Maybe you can remember in this section, microcontroller course from third year. Actually, our course is organized by Four cores. Okay, this is important for us. If you have any knowledge problem, please return your third year, open your old book, open your old notes, please revise you. Okay. Now, next slide, we can see role of electric drive. Actually, we talk about them, role of power processing unit. I said some things about it. Actually, this is a very old market value. Now we have very big market. Maybe we say something. Maybe we say some company name. For example, in the market, ABB, Schneider, also Mitsubishi, Semicron, Delta companies are leader in electric drive market. With the electric vehicle system, some companies have new role. Also, it's interesting point we have. Generally, China market is leader nearly all electronic application. However, in electric drive system, especially wind turbine, especially electric vehicle, especially high technology, high technological sector, Europe, Japan, and USA companies are leader. This is very important. So we can say we can uh, we can pro as a Turkey we have a capabilities and we have some opportunities in power electronic and electric drive system market because China is non-leader in this sector. It's very critical. If you developed high technological product, you can not buy from China. You can produce your own electric drive system. It's critical point. Lots of circuit, lots of electronic components are come from China. However, in this sector, maybe we can organize ourselves and we will be leader as a Turkey. It's interesting. Generally, China, you know. In this sector, Europe, US, and Japan, we have opportunity. Okay. What's the market needs? Actually, last year's market needs focused to electric vehicle. It's interesting because electric vehicle are all of electric drive system parts production. Actually, electric vehicles equal electric drive system, battery, power electronic unit, electric machine, ECU, and controller. Nearly all electrical parts are equal electric drive system. It's a new and biggest opportunity for us. Okay, I think some students will be focused to the electric vehicle need. Okay, it's critical. In this course, I will give some homework for electric vehicle design as an electric drive system. Maybe in your graduation project, you can develop a powertrain. Also, another critical sector, wind turbine. You know the world market for electric drives will be significantly impacted by large-scale opportunities for wind energy. Like electric vehicle, in wind energy sector, Europe and USA are leader. It is another opportunity for us because these sectors are competitive because China has no opportunity because Chinese products low quality sometimes because it's cheap, But the Europe and USA products are very expensive. Maybe as a Turkey, as a Middle East geopolitical position, have opportunities. If we developed quality-based product, we will be competitive in this sector. Okay, it's critical, I think. Also, typical application of electric drives, I said something about them. Um, in electric drive system, our main power range, you see, generally 100 megawatt power maximum. Also another critical factor, speed, generally in space application, etc. 80,000 revolution per minute. Critical point here, we have a curve, you see, high speed. If you need high speed, your motor will be low power. In high power motor, you have low speed. It's critical. Classical equation. Power equal torque times speed. It's your first equation. Actually, it will be basic equation. Power equal torque. Torque is a Newton meter times speed. It's critical. So we can say speed, torque, and power relation. Then, why electric drive systems are growing? Because we have some technical advance in IC. What's IC? IC actually chips. Now we have chip crease. Yes, because we need. What is the chip crease reason? We need we need lots of electric drive system, lots of mobile phone, lots of electric vehicle, lots of charging station, etc. So we have IC creases because electric drive systems are growing. IC, first reason. Also DSP. What's DSP? Digital signal processor. Actually, very high capability microelectronic or microcomputer or microcontroller solution. Actually, 20 years ago we have only peak. Maybe you remember some if you have some age. Now peak is that we have digital signal processor in market. Also we have FPGA. Another reason, semiconductor fabrication technology. It is interesting. For example, 30 years ago, we have only diode, only transistor, only BGT, GTO, and MOSFET. And MOSFETs are expensive. Now we have IGBT, silicon carbide IGBT, high capability MOSFET, etc. So, lastly, market needs. Company Companies needs reduction in energy usage and less maintenance, They use electric drive system in their system nearly 20 years ago, 30 years ago. Okay, in next slide, typical application. I said you classical, maybe we can read together. Process industry. What's the process industry? Pumps, fans, compressor. I mentioned lots of them. Agitators, machining, winch, chippers, drill, extruder, grinder, mills and press. Also, HVAC industry, heating and air conditioning, blower and compressor, paper and steel industry, transportation, train, automobile, elevator. Actually, as Okan University, our main focus in here. Residential, heat pumps, freezer, washing machine, oil and gas industry, pump, crane, compressor, packaging, textile, food, conveyor fans. In your life, you see lots of this application. Washing machine, heat pump, compressor, pump, fan, elevator. They have electric drive system. After first week on this course, probably you will focus where is the drive system. In your elevator, in your apartment, you have drive system. Okay, typical application, electric drive system. First one, air conditioning and heat pumps. What's the heat pumps? What's the air conditioner? You know, conventional air conditioners cool buildings by extracting energy from inside the building and transferring it to the atmosphere. Heat pumps, in addition to the air conditioning mode, can also heat buildings in winter by extracting energy from outside and transferring it inside. It's a very complementary application with the cooling and heating. The use of heat pumps for heating and cooling is on the rise. They are now employed in roughly one out of the every three new homes constructed in the Turkey, in Europe. In conventional systems, the building temperature is controlled by on-off cycling of the compressor motor. I said 20 minutes ago. All the years, we have only on-off, on-off, on-off with the thermostat setting. Maybe you remember from your old home. Climate working on, work off, work on, work off, work on, work off. After being off, when the compressor motor turns on, the compressor output builds up slowly, while the motor immediately begins the draw full paper. This is this cyclic loss between the ideal and the actual values of the compressor output. You can see in your figure. This is our loss on-off control. Actually, our ideal is here. Actual is here. This is loss, energy loss. How can we solve this loss problem with the electric drive system? This cyclic loss between the ideal and the actual values of the compressor output, you can see in your figure, it can be eliminated by running the compressor continuously at a speed at which its output match the thermal load of the building. Compared to conventional system, compressors driven by adjustable speed drive reduce power consumption by as much as 30%. After this class, you can search in the internet what is the inverter controlled air conditioner. Maybe from your childhood you saw in your television, for example, in Turkish market, Arçelik inverter air conditioner. They have inverter. They operated at the reference speed. They have no loss. They are energy efficient systems. Next one, pumps. Not pumps. Pumps is not important. Maybe we can say wind energy. I said you, we will focus some application of electric drive system. One of them pumps. Second one, wind electric generation. Electric drives also play a significant role in power generation from renewable energy source, where such as wind, such as small hydro, micro hydro. Block diagram for a wind electric system in your screen you see where the variable frequency AC produced by the wind turbine. Now we have energy production utility. Um, AC variable frequency AC produced by wind turbine driving generator is interfaced with the utility system. Now we product energy from wind, okay. We have a grid, okay. But we need conversion operation with the variable speed generator and power processing unit with electric drive and control system. By letting the turbine speed vary, with the wind speed. For example, sometimes 1 meter over second, maximum 7 meter, nominally 7 meter over second, sometimes 12 meter over second. It's variable. If it is variable, we need to operate them, we need to control them in utility need. Okay, it's possible to recover a higher amount of energy compared to systems where the turbine essentially rotates at a constant speed due to the generator output being directly connected to the utility grid. Okay, in wind turbine, our main aim, we need to organize variable wind, constant frequency, constant amplitude, utility energy. We will organize it. We will design generator, we will design power electronic circuit, we will design controller. Every time we will obtain constant frequency, constant frequency, constant amplitude, utility, grid energy. In another focus point, yes, electric transportation. As Okan University, our main and critical topics, transportation, electric drives, electric vehicles, autonomous vehicles, etc. This section is important for us in this course. The electric transportation is widely used in many countries, in Turkey, in your country, in Europe, in US, in Iraq, etc. One example, magnetically levitated trains. We have no this opportunity in Turkey. In Germany and Japan, they have magnetically high-speed train. This is the first application for electric transportation. Also, in United States, they have this opportunity. Another important application of electric drives in electric vehicle and hybrid electric vehicle. The main virtue of electric vehicles is that they emit no pollutant. However, electric vehicles must wait. Actually, we have suitable battery, fuel cell, or flywheel to be developed before the average classical, traditional ICE user accept them. In this year, maybe we solve lots of battery problem, maybe lots of powertrain problem. However, we have some range anxiety. In electric vehicle, we need to solve some problem. Probably after 10 years, we will solve in worldwide. There are so many new applications. Another one also not electric vehicle. In your traditional vehicle, we have lots of new application. For example, for example, your hybrid vehicle. For example, your uh, power steering system. This is the typical electric drive system. Power steering system. It's called as EPAS. Also, you have lots of electric machine application on your vehicle. Steering, brake, ESP, ABS, etc. I suppose that in your vehicle, traditional vehicle, I say to you, traditional ICE vehicle, you will see nearly 200 electric motor in one vehicle. It's very critical. 200 electric motors in traditional ICE vehicles. Okay, next one. It's interesting. Electric drives actually, I said you lots of time, multidisciplinary nature. Control theory, power electronic, machine, utilities, sensor, mechanical system modeling, real-time microcontroller DSP control. These are another courses. In this class, lots of students uh, succeed these courses. I hope you will succeed electric drives course. Okay, that's a classical, I said, control theory. Maybe in this course, it's critical as a control theory. All students know the control theory in this course. Speed control, position control, etc. Why is it important? Minimum, you need to know PI control. In this course, minimum criteria. Please learn PI control. What's the PI control? Okay. Maybe you remember from the control course. If you have a, if you know, if you don't remember PI controller, please open your old book. Please learn PI controller as soon as possible. Okay, it's critical. DSP, okay, mechanical system modeling, etc., etc. Okay. Now, it's our first course today. We can finish. Only one, 45 minutes is okay for today. It's just a introduction, brief introduction. Next week, we will start modeling the electric machine with the DC motor. We will start with the DC motor application, what's the DC motor characteristic, control structure, etc. Probably we will build using DC motor all conversion, all drive theory. Also, another thing, please download MATLAB Simulink from MATLAB website. Okay, we will use lots of time MATLAB Simulink simulation program. To the next week, please download MATLAB Simulink. Also, please check your old courses note, especially what's the PI controller. Probably it will be face to face. Your exam summer will be face to face probably. I will upload your syllabus. I will upload your course notes step by step. Don't worry about it. If you have a question, my room number 213, I suppose that, in the first floor of the engineering faculty. In this course, you have lots of homework. Please don't forget it. You will have lots of homework. Okay. Thank you, dear all, for your attendance. Next week, see you. Please check sometimes your all learn document section. I will upload day by day. Okay, see you next week, dear all. Bye bye.